Hello guys. So before we start memorizing physiology, I want you to think about something really simple. Your body is constantly changing, right? You get hot, you get cold, you exercise, you eat, you go without food, you lose water, you sleep, you can never get an infection. You can even get an infection. But despite all these changes, your cells keep working, right? Your heart keeps beating, your brain keeps working, and all those chemical reactions inside your cells continue. So, how does your body manage all of this? That's where one of the most important concepts in physiology ever begins. That is homeostasis. Hope you are all with me. Here we go. And what is homeostasis? So, what exactly does homeostasis mean? We'll find a textbook definition first. So, the textbook definition is maintaining a relatively stable internal environment despite continuous change. But don't just memorize the sentence, okay? I want you to understand what it actually means. Notice the words relatively stable. So it doesn't mean your body temperature is exactly the same every second, and it doesn't mean your blood pressure is exactly the same every second. It doesn't mean your blood glucose is exactly the same every second. All of these things are constantly moving up and down. Your body is continuously making adjustments to keep them within an appropriate range. So, the easiest way to think about homeostasis is the body is constantly adjusting itself to keep its internal environment suitable for life. So, why does the body need homeostasis? Now, here's an important question, right? Why does the body even bother doing all this? Why not just let everything change? Because your cells are actually very picky, like me in food. They need the right conditions to work properly. They need an appropriate temperature. They need the right pH. They need right oxygen. They need glucose per energy. They need the right amount of water and electrolytes. So if all these conditions move too far away from normal, cells start struggling. Like how I am struggling in my life. And if enough cells start struggling, tissues and organs start losing their function. So, homeostasis is basically the body's way of protecting the environment that our cells need to survive. Hmm? Let's forget the complicated terminology for a moment and use something we already understand. Imagine you are walking outside on a really hot day. What happens next? Your body starts gaining heat. Then your temperature begins to rise, right? Then what happens next? You start sweating. And by the way, I have hyperhidrosis. I always sweat a lot, especially my palms. Okay, so what happens next? So you start sweating. When sweat evaporates from your skin, it takes heat away from your body. So sweating helps increase heat loss. And as heat is lost, your body temperature moves back towards its normal range. So look at what just happened. Something changed first. Your temperature increased and your body responded to that change. That idea is the foundation of feedback systems. This brings us to one of the most important concepts in physiology, which is negative feedback. And don't let the word negative confuse you. Negative doesn't mean bad, it simply means that the response opposes the original change. Our temperature went up, the body responded by increasing heat loss. Heat loss brings the temperature back down. So the response is going in the opposite direction of the original disturbance, right? So that's negative feedback. So whenever you hear the negative feedback, think the response fights against the original change. Okay, now let's go the other way. Now let's completely reverse the situation. Okay, imagine you are standing outside in a freezing weather. You are losing heat. Then your body temperature starts falling. What happens now? Now the body has a completely different problem, right? It needs to conserve the heat and produce more and more heat. So what body do? So the blood vessels in our skin constrict. This reduces blood flow through the skin and help reduces the heat loss. And then you start shivering. Shivering is a rapid involuntary muscle activity, and that muscle activity generates the heat. So remember the logic. Hot, then you will lose heat. Cold, then you conserve and produce heat. The body is constantly adjusting according to the problem. How does the body actually do this? Okay, now we are going to convert everything we have learned into a medical terminology. So whenever something changes, we call that change called the stimulus. Something has to detect that change, right? So that's the receptor. The information then goes to the control center. The control center processes all this information and coordinates what need to happen. Then we have an effector. The effector is the part of the body that actually carries out the response from the control center. And finally we get the response. So the basic pattern is stimulus, receptor, control center, then from the control center to effector and response. I want you to remember this sequence because we are going to keep seeing it throughout the physiology and everywhere. Hope you're understanding it. Okay. Let's apply our new framework to the temperature regulation. So the stimulus is change in the body temperature. Temperature sensitive receptors detect the information about the change. Then we come to one of the most important structures for temperature regulation. Can anyone tell me what's that? That is our hypothalamus. The hypothalamus acts as a major control center for thermoregulation. It coordinates the body's responses. Sweat glands can increase sweating. Skin blood vessels can dilate or constrict. Our skeletal muscles can produce the heat through shivering. So now our abstract formula becomes a real physiological system. Okay, remember the hypothalamus, major control center for our thermoregulation is hypothalamus. Then negative feedback versus positive feedback. So far we have mainly talked about negative feedback. But there is another type called positive feedback, and this one works almost in the opposite way. Negative feedback fights the original change. Positive feedback strengthens the original change. Think about it like this. Like negative feedback says, whoa, things are changing, let's bring them back. But the positive feedback says, things are happening, let's make the process stronger and stronger. A classic example, can anyone give me a classic example for that? Exactly, it's a childbirth. So we'll come to that. So during childbirth, the body's head stretches the cervix, right? This promotes the release of, yeah, you know that is oxytocin. Oxytocin increases the uterine contractions. Stronger contractions cause more cervical stretching. More stretching promotes more oxytocin. So we have a cycle where the response actually strengthens the original process. That's positive feedback. But there's something important here. Positive feedback doesn't just continue forever. There is an endpoint for everything. So in this case, the endpoint is delivery of the baby. Okay. Now let's finally connect homeostasis to a clinical medicine. Imagine a patient develops an infection and gets a fever. Here's a question. Is fever simply the body becoming overheated? Tell me in the comments, yes or no. It's a no. In fever, the hypothalamic set point is raised. The body then activates the mechanisms to reach that new higher set point. This is why someone with fever can actually feel cold and start shivering even though their temperature is already high. Their body is trying to reach the new set point. This is really important concept because it helps us understand the difference between fever and hyperthermia. Hmm? Okay. This distinction is extremely important for FMGE. Both fever and hyperthermia can produce high body temperature, but the mechanism is different. In fever, hypothalamic set point is increased. In hyperthermia, the set point does not increase at all. Instead, the body is gaining or producing more heat than it can lose. So if an exam question gives you a patient with a very high temperature, doesn't immediately jump to fever. Ask yourself what happened to the hypothalamic set point. If the set point increased, then that is fever. If the set point didn't increase and the body is simply accumulating too much heat, then think hyperthermia. Hope you all are understanding everything. Let's finish by putting everything together, okay? Whatever we have learned in this lecture. So homeostasis means dynamic stability of the internal environment. Negative feedback opposes the original change. Positive feedback amplifies the original change. The basic homeostatic control system is stimulus, receptor, control center, effector, response. Repeat it with me again and again. Control system have stimulus, receptor, control center, effector, then we see the response. The hypothalamus is a major control center for temperature regulation. Okay, when we are hot, we increases heat loss. When we are cold, we conserve and produce the heat. And clinically, remember the big distinction: fever means set point has increased. Hyperthermia means the set point has not increased. So if you understand these concepts, instead of simply memorizing the words, you have built the foundation for a huge amount of physiology and pathology that comes later. Okay, thank you for listening to my lecture. And today is August 23, 6:42 a.m. because this is the time where there will be no noise in my home. Hope you all understand. Thank you so much for listening.